So today we learn about called periodic signal and aperiodic signal. So we'll discuss about this 6th number. And aperiodic signal, or it's, you can say, non-periodic signal. Okay. So these things you already know. Then also let me give the definitions. What is called periodic signal? Okay? So what is called periodic signal? A signal which repeat its shape after a specific interval of time. It is called a periodic signal. Okay? So what is called periodic signal? You can write like that: a signal which repeat. Signal which repeat itself after a specific interval of time is called periodic signal. So what are the example? Example are like sin t, cos t. These are the periodic signals. Okay. Periodic means so this is the sin t. So you can see if this is the time period, okay? This shape is repeated once again after another time period. So we can say that's why this signal is called periodic. Means its shape is repeating. That's why it is called periodic signal. Okay. So what is called time period? Time period, the distance between two peaks is called a time period, or you can say the time is required for repeat another shape. The time required to repeat its shape once again is called also time period. You can say like that also. 0, pi, twice pi. Here twice pi is the time period. So I think these things you already know. And let me give one condition on which that these periodic signals are should satisfy. Okay. Just take the note. Periodic signal satisfy the following condition. What is the condition? It is x of t plus m of t equal to x of t. Okay. Here capital is what? Time period of the signal. Okay. And what is the m? M is the integer value. What are the integer value? Integer value are like 1, 2, 3, 4, or -1, -2, -3. Okay. There should not be any fractional. If their fractional is there, then that will be a rational number. Okay. This is the condition for periodic signal. Another term is there, fundamental period. What is called fundamental period? Okay. The fundamental period is the smallest time period, okay, of the signal. A signal may contain different frequencies, okay. Different frequencies means different time period, okay. Among the different time period, which is the smallest time period is called the fundamental period, okay. So let me give what is called fundamental period. Is the smallest time period of a periodic signal. Okay. For the smallest, from the relation you can say smallest means for fundamental period m should be 1, okay, or -1. That's okay. Xt plus capital T should be x of t. This is the equation for the fundamental period. So just I have given the definition of periodic signal. What is called periodic signal? It is the repetition of the signal, or you can say a signal which repeats itself after a specific interval of time. Those called periodic signal. Okay. The conditions of the periodic signal is xt plus m capital T should be equal to x of t. And the fourth fundamental period is the smallest time period of a signal. Okay. So what is called aperiodic signal? It is you can write the definition from the above also. A signal that does not repeat itself. A signal that does not repeat its shape, does not repeat itself after a specific interval of time is called an aperiodic signal. Okay. What is called aperiodic signal? A signal which does not repeat its shape, or does not repeat itself after a specific interval of time is called aperiodic signal. What are the examples? Examples are like unity step signal. Unity step signal, I think you know. Already I have discussed so many times. Unity step signal whose amplitude is 1 for the positive time duration. You can see its shape is not repeat. Okay. Or a ramp signal. Ramp signal also you should know. So these signals are not a periodic signal. These are called aperiodic signal or non-periodic signal. Okay. So these are the definition I have given. Sometimes you need the derivation of the time period, okay, t, or derivation of the fundamental time period of the continuous time signal as well as the discrete time signal. So now we are going to derive equation for time period signal, okay, fundamental time period. Okay. Derivation of fundamental time period. Or you can say time. So we already know the condition for the condition for periodicity of a signal is, what is the condition? We know that x of t plus capital T should be x of t. What is this capital T? This equation for the fundamental periodic signal, okay, or fundamental periods, okay. So here T is nothing but fundamental, because M is 1. That's why this T, the time period, is nothing but a fundamental period. So we have to find a general formula, okay, for this. So we have to take a signal to derive that equation. Let we have taken xt is equal to e to the power j omega t, okay, a complex exponential signal we have taken, okay. So so we can say, when we put in 1 this signal xt in the 1, what we'll get? And let me write the equation once again. Let me bring xt equal to x of t plus capital T, okay. So what is the equation? E to the power j omega naught t equal to e to the power minus j omega naught. In place of t, we have to put what? To put t plus capital T. Above there is a plus sign, means omega naught t into e to the power, we can write this one, okay, t, okay. So you can see these things come as it is here, means we have to equate these two signal, okay. The both sides should be equal. When that will be equal? The above condition, when that will be equal? Let me go for the next slide. Take the note. You can see that this is the left side and this is the right side, okay. The both sides equal when e to the power minus j omega t should be 1, okay. When this term, okay, this term will be 1, then only both the side will be equal, okay. So we can we should write like that, then for periodicity, or for maintain the, or to derive the equation for periodic signal, or like for periodicity, we should have what? We should have these things, okay, these things. E to the power minus j omega naught capital T, e to the power minus j omega naught capital T should be 1, okay. Can anybody say when this term will be 1? Can anybody say when this term will be 1? E to the power minus j omega naught t equal to 1.
E power 0.
When t equal to 0, sir.
When capital T equals to 0.
Somebody say capital T should be 0. Somebody say e to the power 0 should be 0. Okay, then this will be 1. Like that is, it's okay, but this t should okay, let me say differently. This t should be 0 means you can say omega naught equal to 0, okay. The fundamental, we take the fundamental, this quantity we do not take into consideration, because we assume that there have some fundamental period, okay. The signal, okay, let me say that one thing is that maybe omega naught equal to 0, then this case would be 1, or you can say when t equal, we do not take this condition t equal to 0, because T is already, we have already taken a quantity that is a fundamental period. We'll take only omega not equal to 0. The first case is that if omega not equal to 0, okay. So omega not equal to 0 means, what do you mean by omega not equal to 0? Omega not equal to 0 means twice pi f not equal to 0, or you can say f not equal to 0. F not 0 means what? F not 0 means the signal has no frequency term. Okay. If there is no frequency term, then the signal will be what types? Signal will be a constant amplitude or constant signal, you can say. Okay. Which has a time period would be infinity. Okay. T equal to 1 by 0 means infinity. Like that. So we can say then xt is a periodic signal for any value of t. So this is not our consideration, because signal, most of the signal where omega naught is present, okay, means some frequency is present. Okay. So there is very less signal which has infinite time period, or frequency time is 0. Okay. We'll take as a case that if omega naught equal to 0, then this condition will satisfy, e to the power minus j omega naught equal to 1. Okay. But other case is there. Okay. Other case, what types of case? That suppose, because most of the signal omega not equal to 0. Okay. Then what is the case for this will be 1. Okay. Let me explain first. So what is the equation for j omega naught t? Can you say this is cos omega naught t, okay, plus or minus? If there is minus, then it will be minus, or if there is plus, then it will be plus. Okay. And minus sine omega naught t. Okay. So when this will be 1, then you take some twice pi. Okay. When you take twice pi, then this term will getting to 1. Okay. You put there and you see what I am saying, that this omega t should be equal to twice pi. Then this term going to be 1. How? Have you understand this? Twice pi, sine twice pi means how much? Sine twice pi means 0. Okay. What is cos twice pi? Cos twice pi means 1. That's why this term will be 1. So our condition, another condition is, when there this omega not equal to 0, then the above equation, this equation will be 1 when then the fundamental period, when then fundamental period t of xt holds the following condition. What is the condition? This omega naught t should be twice pi. Okay. Understood? Because when you put this omega naught equal to twice pi, this cos twice pi minus sine twice pi, cos twice pi means 1 and sine twice pi means 0. it is 1. Or you can write this, you can make it like a 2, this like a k also. You can make it like a 4 pi, 6 pi, like that also. Understood? It will be 1. This term will be 1 when you put here cos twice pi or sine cos 4 pi or cos 6 pi or cos 7 pi. For all the value of pi, the sine term would be 0. There is no case. Only pi, if there was pi by 2, then sine value will be 1. But if there is pi value in the theta for sine, all the term, that will be 0 only. But for cos, only the positive term is 2, 4, 6. The equation will be, means the equation will be given 1. Okay. So we can write here k also. Okay. Omega naught t equal to twice by k, where k equal to, what is the value? Maybe 0 or plus minus 1 or plus minus 2 or anything. Okay. Because when I have put 1, it is twice pi. When 2, 4 pi, 3, then 6 pi, like that. So condition is, what is the condition? T equal to twice pi by omega naught into k. Understand? This is the condition, and we will take for k equal to 1. What is the condition? Ultimate condition? Twice pi by omega naught. This is the equation for fundamental period. T equal to twice pi by omega naught. Understood? Have you taken the note? So this is this is very important equation, because sometimes they will give only sun time or cos time, and they will say find the time period. Okay, then you have to use this this equation, t equal to twice pi by omega naught. So then come another note. That was the derivation for the time period for continuous time signal. If same equation can be found for periodic signal also. Okay. Now for the discrete time signal also, let me give that equation. This is very important. Discrete time signal. And is the fundamental period for discrete time signal equal to twice pi by ohm into k. Okay. Where k value is 1, 2, 3 up to this. This should be only positive value for discrete time signal. This should be only positive value. And another condition is that the n must be here, n must be a integer value. This is a compulsory condition. Okay. Here we cannot put only k equal to 1, and we cannot derive the fundamental period for discrete time signal. We should put the k value in such a way that the n value become an integer value. But here in this continuous time signal, will for k equal to 1 we have taken, and we can find any value for t. There has nothing condition. There is no condition should be satisfied by this equation, that time period should be rational or irrational or integer value. Not time. This time period should be may have a rational number. Okay, may be integer. There has no condition for continuous time signal, but for discrete time signal, one condition is that the time period should be an integer value. Okay, these things you should remember. So have you taken the note? So come to the another note. The note is that you can write heading as a condition of the periodicity. Condition of if we sum up two signal, then what will be the period of that signal? Sum of two signals. Thing you saw about the condition of periodicity for sum of two signal. Okay. Suppose if two signal are summed up, what will be the period? There is some condition. Let me write. Suppose if x1 t and x2 of t are two periodic signal. Okay. So the t1 and t2 respectively. Then those the signal will be periodic. Means then x of t equal to x1 of t plus x2 of t is a periodic signal. Okay. Sum of the signal will also a periodic signal. If condition is that the t, the resultant period, okay, after sum, what is the period of the xt, t should satisfy n into t1 or m into t2. Okay. Or you can write and another condition is that t1 by t2 should be equal to m by n, or you can write like that. That will be the, you can make, you can write like this. So what is m, n or t, t1? What is the relation? You can write like this, where t1 by t2 should be m by n. What is the m or n? This is the integer value. M or n are the integer value. And you can say another thing, this t1, t2 should give a rational number. Should give a what? A rational number. This is the condition. T1 by T2 equal to m by n equal to should produce a rational number, where m or n is the integer value. Okay? So if we get the value of n or m, when you multiply with t1 or m multiply with t2, we'll find the value of t. Or we can find value of t like value of t is the LCM of T1 or T2. T1 or T2. This is another note that if you find this M or N below, then also you can find the T below. Okay, by multiplying N into T1 or M into T2. This is one case. We can find the time period of the resultant signal or summed up signal, or we can find the time T, the time period T, by taking the LCM of T1 or T2. Okay, this is two way we can find the time period. This condition you should remember that T1 by